Lesson 5-8. Subtracting mixed numbers. The focus in this lesson is for you to solve a subtraction number story involving mixed numbers. Then you will be able to discuss how to subtract mixed numbers with like denominators. And finally, I want you to solve subtraction number stories involving fractions and mixed numbers with like denominators. But first, let's take a look at our mental math and fluency. Look at the fractions on this screen. 1/2 equals 4/5. Well, hopefully you realize if you got out your pieces, your circles, or if you drew it, you would realize that half is quite a bit smaller than 4/5. 1/3 plus 2/6. I'm sorry, you're not adding. 1/3 equals 2/6. Well, if you look, 3 times 2 is 6, and 1 times 2 is 2, so they are equivalent. And our final one, 3/6 equals 1/2. Anytime you see 1/2, you should be looking at the other fraction and asking yourself, is the top number half of the bottom number? And instantly you notice that 3 is half of 6, so both of these are equivalent to each other. Read this to yourself as I read it out loud. It says, solve this problem. Be prepared to show or explain how you got your answer. Use fraction circles or the number line poster to help. The art students had 3 2/3 gallons of paint for the school play scenery. They used 2 1/3 gallons. How many gallons were left when the students finished painting? So let's take a look at one strategy we can do to come up with this answer. So 3 2/3 of paint for the school play secretary. Well, one way you could look at that is you could look at it using a number line. Now I'm sorry this is not completely straight, but you should know that at the beginning we would start with 0/3 and then go up to 1/3. And then again to 2/3, and finally to the whole, which would be here, the number 1 whole, which actually is going to equal 3/3. When the top and the bottom number are exactly the same, they are a whole. And let's continue. Then next we would have 4/3, and then 5/3, and again 6/3. 6/3 is like saying 6 divided by 3, which is 2 wholes. Then next we have 7/3, 8/3, 9/3, which again is like saying 9 divided by 3 is 3 wholes. Then we have 10/3, 11/3, and sorry for my handwriting here with the cursor, and 12/3. And again, 12 divided by 3 is 4. So at this point on our number line is 4 wholes. The next instruction says that they used 2 1/3 gallons of paint. How many gallons were left when the students finished? So looking at 3 2/3. So this would be 3, 1/3, 2/3. So I'm going to mark an X here where I'm starting. This is where the amount of gallons of paint is what I started with. And it says they used 2 1/3. So every gallon we said is 3/3. So we got to count back a total of 6 for 2 full gallons. So there's 1, there's 2, there's 3, there's 4, there's 5, there's 6. But it said 2 1/3. So if I need another third, here is my answer. That's how many gallons of paint I have left. So I either have 4/3, or we could write that as 1 whole, and the first line after it would be 1/3. So 4 1/3 equals 1 1/3. Another strategy you could do, again, is show that 3 2/3 equals 3 plus 2/3. So now what I'm doing is basically just writing as a number in fractions, which equals, again, my 9/3 plus the 2/3. Remember, 9/3 is like 9 divided by 3 plus the 2/3 for a total of 11/3. And if you look, that's exactly where I started on my number line. And then the 2 1/3 would equal 2 plus 1/3. Again, sorry for my handwriting. Which this time, the 2 equals 6/3. And if you look above again on our number line, that's what we had written. Plus the 1/3 equals 7/3. Now we take our original 11/3, we subtract the 7/3, and we get 4/3. So there's two different ways you could solve that problem. You could use it on a number line, walk yourself through it like I just did. You could change your numbers into fractions and then subtract them. Or another way is that you could get out your circle pieces and you could lay them out and put 1, 2, 3 red circles and 1/3 fraction pieces, and then get the other 2 1/3 fraction pieces out, and then actually show them being pulled away to come up with your answer. So there's multiple ways you can come up with your answer to that problem. Next, you're looking at another problem to be solved. Read it to yourself as I read it out loud. It says, solve the number stories on this screen and the next. Use a different strategy for each one. Raphael drew 2 line segments. The combined length was 7 inches. One of the line segments was 2 3/8 inches long. So it's giving you that fact, that information right now. It's 2 3/8 inches long. How long was the other line segment? Get out your math journal and turn to page 171. This is problem number 1 on that page. So, right away, your number model should say the information that we know. The combined length was 7 inches. So we know the total is going to be 7. One of the line segments was 2 3/8 inches. I'm sorry, I drew an equal sign when I wanted to draw a subtraction sign. So I know I'm taking away 2 3/8 inches. And I'm going to put L for line segment as my variable for the unknown. So I'm going to be taking 7 minus 2 3/8 equals line. And what's my whole? We already said my whole is 1 inch. One way to solve this mixed number problem is, again, rename 7, like we did with the numbers earlier, as 6 and 8/8, so there are eighths to subtract. So we could take 6 and 2/8, I'm sorry, an 8/8, if I get this right here, minus the 2 and 3/8. I'm going to make this a capital L so you don't think that stands for the number 1, equals, well, 6 minus 2 is 4. The denominator stays the same because they are both 8 already. And then 8 minus 3 is 5. So my answer is 4 and 5/8. And it says to give the units with units. Units is inches. Let's go ahead and let's rename this 4 and 5/8. Well, if we want to figure out what 4 is, we know 1 is 8/8. The number 2 would be another 8/8. The number 3 would be another 8/8. The number 4 would be 8/8. And then we have the 5/8 here that's still in the answer. Remember, when adding fractions with like denominators, it remains the same, and all we do is add the numerators on top. 8 plus 8 is 16, plus 8 is 24, plus 8 is 32, plus 5 is 37. So my answer is 4 and 5/8 inches, or 37/8 inches. Finish page 171, and this is an assessment check-in. So when you complete the entire page, I want you to bring it up to me so I can check your answers to make sure you understand what you're doing before you go on. So pause the recording now and please complete Math Journal page 171. Once I've checked Math Journal page 171, you are going to go on to Math Journal page 172. And I am going to read the problems to you so you can follow along. Rewind the recording if you need to in order to play it a second time to make sure you understand what you need to do. So Math Box 1 on page 172 reads, 6 boxes of gumballs spilled onto the floor. Bonnie picked up enough to fill 2 1/6 boxes. Carl picked up 2 2/6 boxes, and Betty picked up 1 2/6 boxes. How many boxes of gumballs did they pick up? I hope you're realizing that if one picked up some and another one, that you're going to need to add these fractions together. And then it says, did they find all of the gumballs? Remember, originally there were 6 boxes, so you need to figure out if you picked up enough boxes to equal 6 to answer the second question. Pause the recording now and do Math Box 1 on page 172. Math Box 2. Draw 2 rays with the same endpoint. Label the endpoint E. Label a point on each of the rays. Okay, so you're drawing 2 rays with the same endpoint. So they're going to be connected. The dot in the middle of the ray at the end of both is going to be the same letter E. So one ray is going to need to go off to the right. This is kind of a complicated thing. So you're going to have one ray going, and I'm not at all drawing this correct, this way. And this is going to be your endpoint E. And your other ray is going to go up like in that direction. If you don't remember what a ray needs, does it need an arrow on the end? Doesn't it? Turn to your SRB, page 226 or 228, and it'll show you what you need to make a ray. Stop the recording now and do Math Box 2. Math Box 3. A lamp at Betson's Lighting costs $26.